Okay, so now we're going to move into the waste-gated type of turbo. Our last one we were talking about this fixed geometry. Fixed geometry means there's no controls on this turbo. The only control it has basically is how much exhaust flows through it, determining how much boost that you have. So that was the fixed geometry. And we went over the problems with that, with low RPM, emissions, the turbo lag, basically not doing much at all at low RPMs and only kicking in at high RPMs, and all these things were problematic. We talked about in the last video. So in the 80s, about the time we really started using turbochargers and diesels for on-road, the fixed geometry started to be phased out. Now there still was some engines after that that were fixed geometry, like this one that came off of a Mack truck. The N14s you worked on in the shop don't have any kind of controls on those, so they're a fixed geometry, but emissions kind of determined and drivability problems that we needed to address that issue. So the first thing we went to was what was called a waste-gated turbo, and we're still using that technology today, although not as much. So what a wastegate allows us to do is use a smaller turbine housing. So I've got this tiny little turbo here off of a 3.3 Cummins, but if you look at it, the turbine side, or the hot side, is actually a smaller housing. It's not a whole lot, but it's a little bit smaller housing than the compressor side, or the cold side of this compressor. That's because it has this wastegate control here. So the theory behind a wastegate and what makes it work is we can put a smaller housing, have that small AR number, which we'll get to later, but a small area and nozzle in the turbine side of the turbocharger, so that at low RPMs we get a lot of velocity out of it. It spins a lot faster at lower RPMs. It gives us boost at low RPMs, so better throttle response, better emissions, more air in the cylinder at lower RPMs and lower loads, which before would have been problematic with a fixed geometry, because at high RPMs and high loads that becomes a restriction. If you have a restriction in exhaust, you can't get the unburnt fuel out of the cylinder, not enough oxygen in. So anytime you have restriction on the exhaust side, it's going to rob you a little bit of engine performance and give you some drivability problems possibly. So they came out with this wastegate that works pretty good at relieving that. And all it is inside here, this is spring-loaded closed, but there's a little valve inside, a little flap basically, or a door might be a better way to think of it. So at a predetermined, generally boost pressure, which coming off the outlet of the compressor side, we've got a diaphragm here. So that boost pressure is acting on this diaphragm inside here, working against spring tension. So at a predetermined boost, this diaphragm is moved against the spring tension, so it overcomes spring tension, moves this linkage, and opens a little door inside this turbo and allows part of our exhaust gases that's trying to get out of the exhaust manifold to bypass the turbine wheel and go straight out the outlet here to the pipe going down to the muffler and tailpipe and whatnot. So all it is if you think of, so you got a bunch of people trying to get through a door. Well, if the crowd gets too big and everything's getting compacted and restricted, if you had another little door over on the side to open up and let part of the people go out that door, then flow would still be okay to get out of the room or whatever. So try to think of it kind of as that way. It's better to have that one door, right? But if the crowd gets too big, or I get too many people wanting to leave at the same time, I may have to open another door somewhere and let somebody else out. Think of it as traffic. One exit out of a parking lot. Everything starts getting backed up. You need to open another exit and let part of the people go out that one. So that's kind of how a wastegate works. But just remember that it's spring-loaded, closed. It has an actuator that opens at a predetermined boost and allows another way out basically for that exhaust so it doesn't become restrictive or too restrictive. As far as the controls, the simple wastegate here, which is a really simple type of wastegate, is just straight off of the boost pressure. It's got a hose coming over here acting on that. I can use vacuum or air or electric to control the position on the wastegate. But to do air pressure, vacuum, or the electronic controls, then I have to have a OBD2 engine that has a computer monitoring boost pressure and monitoring all these conditions to determine where the wastegate needs to be at that particular time. So this is a non-electronic engine, so it doesn't have any of that. It's just using the boost pressure itself to operate. These are critical because there's an adjustment on this wastegate, and there's special tools to position the wastegate, and there's a procedure to go through and adjust this wastegate to be sure that it's going to open and close at the proper settings and everything for it to work. So part of the tune-up on this engine would be adjusting this wastegate, the linkage on it, to make sure it's all set properly, so it's closing all the way and opening at the right PSI. So there's a kit that you would use to set that. With an OBD2 engine, we have a computer monitoring this, so we don't really have to have an adjustable control because the computer can compensate based off of what it's reading and seeing and all that. So just remember that OBD2, an electronic controlled engine, may have an electronically controlled wastegate. So it can use, Detroit uses air, so the air system for the brakes, it takes an air line off of that, lets a solenoid regulate and a regulator regulate how much pressure is going to the boost control to determine exactly what position the wastegate's in, how much it's letting out or how much it's allowing to bypass. Some engines have a vacuum pump and the wastegate is vacuum controlled, but then you also have to have a computer controlling the vacuum to regulate it. And then electronics is obviously straight off the computer with an electronic control to regulate it. So that's pretty much how wastegates work.